Hi, I'm Daniel Garner, and I'm the captain of the 2020 Copley Engineering Gold Team. Our team includes Megan Hersey, Jasmine Walker, Richard Bousfield, Raquel Goins, and Hannah Oldham. This year, our team designed the Nozzleator, an assistive device that helps workers seat a rubber piece comfortably in a plastic nozzle. This year, we decided to work with Weaver Propak, a company that specializes in kitting, packaging, and assembling. Weaver Propak employs people with disabilities, including our SME, Carolyn.
One of the jobs that Weaver Propak has is the seating of a rubber piece in a plastic nozzle. In order to figure out Weaver's concerns and how we could best help them, we visited their Akron campus. While we were there, we interviewed the manager, Amber, and asked many questions about what their current process is and how it could be improved in order to figure out what would be ideal for them. She informed us that they were facing the issues of inconsistent speed and a loss in productivity throughout the workday. She suggested many helpful improvements to our current model, including to enlarge the current prototype to enable more workers to engage in the same task. After conversing with the supervisor, we spoke with an employee. We asked the worker what we could do to make their job easier. They said that one of the most serious problems they face is muscle fatigue. This pain in their hands leads them to slow down and become less productive throughout the workday.
The beginning of the Nozzleator came about when all the team members drew out designs and ideas to complete the task. Throughout the entire process of building and improving designs, we used CAD to carefully create pieces and parts to construct our product. These prototypes range from presses, conveyor belts, to gears running together. The other prototypes included many other flaws that we discovered. We settled with the initial idea of the conveyor belt. The first prototype was made of wood. The main issue with it was that the wheel would shift from left to right and would not maintain a straight alignment. We worked on improving the efficiency of the design by creating an oval track consisting of lengths of track and semicircular end caps. In the end, the nozzle holders, end caps, and two gears were made out of PLA printing plastic. One of our custom gears was a drive gear and was controlled by a motor, and another support gear was added to provide a smoother motion. We believed that this was going to be our final prototype, but due to the immense amount of friction and expense of the parts, we decided to opt for an alternative, cheaper mechanism that provided more reliable results. Our final design had a base and a stand for the wheel, both made of wood. We used one of the gears from the original design to function as the base for the wheel in our machine. Around this wheel, we were able to attach the holders that the nozzles were seated onto. We have a similar wooden wheel that functions to push the rubber pieces into the nozzle as the wheel rotates.
This is the final version of the Nozzleator. Our final design has many unique features that have been developed throughout our other prototypes. It operates using a primary wheel that is surrounded by our custom nozzle holders. This wheel is suspended by these supports here, and underneath there's a ratchet to prevent the wheel from skipping backwards. On the top, the piece that is used for pushing the rubber stoppers into the nozzles themselves. This wheel acts as a barrier to push the rubbers into the nozzles. This device is operated by loading the nozzles into the nozzle holders on the top, and then the rubber is gently placed in the top of the nozzle. The wheel is then slowly rotated around, and more nozzles and rubber pieces are put into each of the nozzle holders.
Our device has significantly improved worker satisfaction because of its easy-to-use nature and the fact that it decreases the amount of pain in the joints of our employees. Our device also helps reduce fatigue because, unlike the old way the workers were doing the job, our device does not require significant muscle strength to do, so it does not lead to fatigue. The employee that worked with our device expressed gratitude and excitement towards the device. After several times of running it, she said, "Neato, that's neat. I like that. It makes it easier on me." Our device has also improved employer satisfaction because with our device, the speed and productivity of the workers is more consistent, even as the workday progresses. Our device has measured an increase in speed from 27 seconds a nozzle to 9 seconds a nozzle, which is a 300% increase in speed. This leads to a more productive work environment and greater employee satisfaction from increased productivity. It also allows an employee to do 3 to 4 nozzles at a time instead of 1 at a time. Additionally, it allows a greater number of employees to do this job because it does not require a great amount of hand strength, which many employees do not possess. In conclusion, the Nozzleator greatly increases employee satisfaction, reduces time spent on the task, and reduces muscle fatigue, making it a valuable addition to Weaver Propak's workplace environment.